Learning objectives. At the end of this topic, you will be able to understand Euclid's definitions, axioms, and postulates. Understand equivalent versions of Euclid's fifth postulate. Introduction. What is geometry? The word geometry comes from the ancient Greek word geo, meaning the earth, and metron, meaning to measure. Geometry is a branch of mathematics concerned with the questions of shape, size, relative position of figures, and the properties of space. Geometry was being applied and developed in ancient time. In the ancient world, they were passed on from one generation to the next, either orally or through palm leaf messages or by other ways. A Greek mathematician, Thales, was the first mathematician who gave first known proof in geometry. This proof was of the statement that a circle is bisected by its diameter. Euclid, a teacher mathematician in Egypt, collected all the known work and arranged it in his famous treatise and one book called Elements. He divided the elements into 13 chapters, each called a book. These books influenced the whole world's understanding of geometry for generations to come. Euclid deduced the principles of what is now called Euclidean geometry from a small set of axioms. Euclid's definitions, axioms, and postulates. Euclid began his treatise by defining the concept of a point. Look at this point. Can we see this point on the screen? Actually not. Let's magnify it and we would be able to see the point. The first definition says that a point is that which has no part. By no part, Euclid meant that the point does not occupy any area in space. In particular, the geometric points do not have any length, area, volume, or any other dimensional attribute. The second definition is about the concept of the line. A line is a breadthless length. A line has only one dimension, namely the length, without any width or depth. In other words, we say that this can be interpreted to mean that a line is a construct that has no thickness. The definition is, the ends of a line are points. Here Euclid talks about a line segment is a part of a line that is bounded by two distinct endpoints. The fourth definition says that a straight line is a line which lies evenly with the points on itself. The straight line is formed by a collection of points which lies evenly along the straight line. The fifth definition states that a surface is that which has length and breadth only. A shape that has only two dimensions such as length and breadth and no thickness. The sixth definition states that the edges of a surface are lines. It's implicit in this definition that every surface is necessarily of finite extent. The seventh definition states that a plane surface is a surface which lies evenly with a straight line on itself. This means that the extremities of a plane surface are straight lines and that the surface lies evenly with them. Thus, we have seen the 7 definitions proposed by Euclid. With these definitions, Euclid tries to describe the fundamental elements of geometry. 1. A point is that which has no part. 2. A line is a breadthless length. 3. The ends of a line are points. 4. A straight line is a line which lies evenly with the points on itself. 5. A surface is that which has length and breadth only. 6. The edges of a surface are lines. 7. A plane surface is a surface which lies evenly with the straight lines on itself. To conclude, he tried to explain about the concept of dimensions and the elements associated with it, like a point has no dimensions, a line has one dimension, and a surface has two dimensions. Euclid's postulates. Postulates are statements which do not require any proof, are self-evident, and deal specifically with geometry. The postulates stated by Euclid evolved from the concept of point, straight line, and surface. Euclid stated 5 postulates. We now go on to list Euclid's choice of postulates. The first postulate states that a straight line may be drawn from any one point to any other point. As this postulate stands, it simply says that every pair of distinct points can be joined by a straight line. Euclid included the additional assumption that any two points can be joined by at most one straight line. He has frequently assumed, without mentioning, that there is a unique line joining two distinct points. Let us state this result in the form of an axiom as follows. Given two distinct points, there is a unique line that passes through them. For more understanding of these postulates, let's start with 2 points. Let's try to find out how many lines can be drawn through the points. We can observe that an infinite number of lines can be drawn through the points. Euclid preferred the straight line passing through the points. The straight line is the shortest line that connects the 2 points. This means that any 2 points can be connected with a unique straight line. The second postulate states that a terminated line can be produced indefinitely. For a terminated line, there are 2 endpoints. A part of a line that connects 2 distinct endpoints is called a line segment. This line segment extends infinitely far in both the directions. The third postulate states that a circle can be drawn with any center and any radius. In other words, given any line segment, a circle can be drawn having the line segment as a radius and one endpoint of the segment as a center. The fourth postulate states that all right angles are equal to one another. Consider 2 right angles, A and B. Angle A is equal to angle B, since both are right angles. Let's arrange the angles in such a way that the orientation of the angles changes. You can observe that even after the change in orientation, angle A is equal to angle B. The fifth postulate states, if a straight line falling on 2 straight lines makes the interior angles on the same side of it, taken together, less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than the 2 right angles. This postulate is also called a parallel postulate. Consider 2 lines parallel to each other. Observe these 2 parallel lines will never intersect at any point. 2 lines that are not parallel will intersect at some point. Here Euclid describes an important property that helps verify if 2 lines are parallel or not. It's done with the help of a transversal line intersecting the lines. If the sum of the interior angle is less than 180 degrees, then the lines are not parallel to each other. To verify this, we produce the lines further. These lines will intersect at one point and form a triangle. This is the reason why the sum of the interior angles of the line is less than 180 degrees. A straight line may be drawn from any one point to any other point. A terminated line can be produced infinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another. If a straight line falling on 2 straight lines makes the interior angles on the same side of it, taken together, less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. Now let's discuss some common notions. These notions are called axioms. On the other hand, were assumptions used throughout mathematics and not specifically linked to geometry. However, we would try to understand these axioms through examples. Remember, these axioms are not restricted to geometry. The first axiom is stated as, things which are equal to the same thing are equal to one another. Let's try to understand these axioms. Let A and X be 2 line segments with equal lengths. Let B be another line segment whose length is also equal to X. This implies that the lengths of the line segment A and B are equal, since both are equal to the same line segment. If we consider A, B, and X as numbers, this axiom corresponds to the transitor property. The second axiom states that if equals are added to equals, the holes are equal. Let us take two lines A and B which are equivalent length. When A and B are added separately to another line segment X, the resulting lengths A plus X and B plus X are equivalent length, since the line segment A and B are equal. The third axiom is about subtraction. If equals are subtracted from equals, the remainders are equal. Let the line segment A and B be of equivalent length. Let X be any other line segment. If we remove the length of A from the length of X, we get X minus A. Similarly, remove the length of B from X, we get the result X minus B. On comparing the length of X minus A and X minus B, we observe that they are equal. Hence, we can conclude, since line segments A and B are of equivalent length, the length of X minus A and X minus B are equal. The fourth axiom states, things which coincide with one another are equal to one another. Let's consider two lines A and B which are equivalent length. If two things are identical, then they are equal. In other words, everything equals itself. The fifth axiom states that the whole is greater than the part. This statement is about the comparison of two objects or quantities. In other words, this statement gives us the definition of greater than. Consider the line segment. That is, split the line segment into two parts. Now you can observe that the length of any split part is less than the length of the whole line segment. Or in other words, we can say that the length of the line segment is greater than the length of its split part. The sixth axiom states, things which are double of the same things are equal to one another. Let A and B be line segments with the same length. When line A is doubled, the length of new line will be equivalent to the line segment B doubled. The seventh axiom states that things which are halves of the same things are equal to one another. The statement is converse of the sixth axiom. Let A and B be two line segments of the same length. When the line A is halved, the length of the new line will be equivalent to the line segment of B if it is halved. Let us see a few examples here. If P, Q, and R are 3 points on a line, and Q lies between P and R, then prove that PQ plus QR is equal to PR. In the figure given above, PR coincides with PQ plus QR. Also, Euclid's axiom 4 says that things which coincide with one another are equal to one another. So it can be deduced that PQ plus QR is equal to PR. Note that in this solution, it has been assumed there is a unique line passing through the 2 points. Prove that an equilateral triangle can be constructed on any given line segment. In the given statement, a line segment of any length is given, say, PQ. Using Euclid's postulate 3, a circle can be drawn with any center and any radius. So you can draw a circle with point P as the center and PQ as the radius. Similarly, draw another circle with point Q as the center and QP as the radius. The two circles meet at a point, say S. Now, draw the line segments PS and QS to form triangle PSQ. So you have to prove that this triangle is equilateral. That is, PQ is equal to PS is equal to QS. Now, PQ is equal to PS, since they are radii of the same circle. Similarly, PQ is equal to QS, radii of the same circle. From these two facts and Euclid's axiom that things which are equal to the same thing are equal to one another, you can conclude PQ is equal to PS is equal to QS. So triangle PQS is an equilateral triangle. Now consider the theorem. Two distinct lines cannot have more than 1 point in common. Consider the two lines L and M. We need to prove that they have only 1 point in common. Let's suppose that the two lines intersect in two distinct points, say P and Q. So you have two lines passing through two distinct points P and Q. But this assumption clashes with the axiom that only one line can pass through two distinct points. So the assumption that we started with, that two lines can pass through two distinct points, is wrong. Hence, two distinct lines cannot have more than one point in common. Equivalent versions of Euclid's fifth postulate. In geometry, the parallel postulate, also called Euclid's fifth postulate because it is the fifth postulate in Euclid's Elements, is a distinctive axiom in Euclidean geometry. In two-dimensional geometry, fifth postulate states that if a line segment intersects two straight lines forming two interior angles on the same side that sum to less than two right angles, then the two lines, if extended indefinitely, meet on that side on which the angles sum to less than two right angles. There are several equivalent versions of this postulate. One of them is Playfair's axiom, as stated as: for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. From this figure, we can observe that all the lines passing through the point P, only line M is parallel to line L. This result can be stated as: two distinct intersecting lines cannot be parallel to the same line. Summary. Let's summarize the topic. The word geometry comes from the ancient Greek word geo, meaning the earth, and metron, meaning to measure. A Greek mathematician, Thales, was the first mathematician who gave first known proof a circle is bisected by its diameter. Euclid, a teacher mathematician in Egypt, collected all the known work and arranged it in his famous treatise in one book called Elements. Thus we have seen the 7 definitions proposed by Euclid. 1. A point is that which has no part. 2. A line is a breadthless length. 3. The ends of a line are points. 4. A straight line is a line which lies evenly with the points on itself. 5. A surface is that which has length and breadth only. 6. The edges of a surface are lines. 7. A plane surface is a surface which lies evenly with the straight lines on itself. The following are some of Euclid's axioms. The 5 postulates of Euclid's were: a straight line may be drawn from any one point to any other point. A terminated line can be produced infinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. 2 equivalent versions of Euclid's fifth postulate are: for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Two distinct intersecting lines cannot be parallel to the same line.